All right, my sex people. So we're gonna do this. So welcome to my physics class, and today I'm gonna show you guys how to make a battery off of things that you'll find in your normal fish tank. Anyways, let's get started. So what you're gonna need is basically you're gonna need two containers. I chose these clear ones. Ideally, you want to make them out of glass, but I just chose plastic because I didn't have small ones. I don't want to use my fish ones because those are just for fish. Um, and then I got this little tube right here. It was actually also part of my tubing. So when I siphon out the sand off of my aquarium, basically I heated it up and I started twisting it, as you can see, and eventually I made this little shape. And it's kind of hard. So this is gonna be like a little bridge right here, like bam. You see that? And then another thing you need is this is a little LED light. Hopefully mine works. I bought this a long time ago, so hopefully it works. If it doesn't, we'll try to power up something else. Another thing you need are these little clips. So there's a red and the black, and we'll talk about that. And then you're gonna need some gelatin, some gelatina. Get some one that's not flavored. Get the flavorless, the gelatin, or also called agar, something like that. Usually Vietnamese or Asian people know about that. But I just got a little bit of gelatin right here. It's all basically the same crap. All right, so anyways, oh yeah, and then you're gonna need a little mixing cup. Next thing you need are these little clips. So it's gonna be raw, so it's not gonna be like edited or anything. So all the little mess ups is basically what you're gonna see. So I got these little clip thingies, and they're basically little pipe holders. So, and these are made out of copper. So you want to make sure these ones are made out of copper, at least for this experiment. In the lab, we use platinum because platinum won't react with the metals or I mean with the chemicals. And another good metal to use is actually gold and then silver. So when you open up your chemistry book, go to the activity series section of the book, and basically you'll see the activity series chart and you'll know exactly what I'm talking about. All right, so these things are made to hold copper pipes for your plumbing. So for fish tanks or any kind of plumbing, there's these little copper things, and it basically holds the little copper pipe right here. And basically I'm just going to try to straighten them out as much as possible. I mean, you could get a hammer if you want. So this one has like two little holes, so I thought that was pretty cool. Another thing you need is basically vinegar. So vinegar is going to be one of our ingredients. So this is our top secret vinegar right here. So Henry's vinegar, or the HCB chemistry vinegar. Oh shit. And then we got some baking soda. So this is some baking soda you can just buy anywhere. All right, so anyways, you can buy these things anywhere. So I'm not sponsoring any of these brands. That's why I'm just making up all these names and stuff. Also, another thing you need is some salt. Make sure it's non-ionized salt. So this is the sea salt. This is my chemistry salt for this aquarium. This is a 5-gallon mixture. If you're gonna do this experiment, you could order the 1-gallon mixtures online, but this is the little 5-gallon mixture that I'm gonna use. Plus I need to mix 5 gallons later on for my aquarium. I think I even got some already open somewhere. Actually, no, I don't. I used it up for my last water change. All right, so yeah, so you're gonna need some salt, and the ocean's made up of different major elements, and basically I'm just gonna mix it up right here real quick. But really, you just want to get the main ingredient in here, and just gonna need a little bit of that. You need some hot water, so I'm just gonna turn on the hot water real quick. Part of this top secret lab, I got a little sink and water system to my right, and then right here I got my fish tank. You could even hear the little bubbling. I got electrical, everything right there perfectly. It's all set up pretty awesomeness, I think. All right, so another thing you need honestly is your glasses. So before you start anything, make sure you have glasses. I don't have any clear ones, so I'm just gonna use these. And for my lab partner, which is you, I got one right here for you. You can grab it here whenever you want. All right, so yeah, so make sure you put your glasses on. All right, everybody. So I'm not gonna lie. So this is after production. So after I basically did the original video. So in this section, I'm just gonna tell you how I made this salt bridge. So to make this salt bridge, basically what you want to do is have some hot water. So just pour some hot water in here, and then what you want to add is you want to add some salt. Okay, so make sure you go to my website, go to hcbchemistry.com, and you could just add a little bit of salt and just get like the 1 gallon size. Don't get the big sizes. And if you don't know how much salt to add, just add a whole bunch. So bam, that. See that? So this is all my saltwater mixture. So when I go do my water changes for my salt, and that's basically a 5 gallon. I'm still gonna use it for my water mixtures. All right, so what we want to do is mix it up real quick. All right, so once you get that done, what you want to do is add a little bit of gelatin. All right, probably add like 2 bags or something. There you go. All right, so this is basically our first step to make the battery, okay? Or it could be the last step. It doesn't really matter. But like I said, this section of the clip is just basically after I edit everything, and I noticed because my camera keeps failing on me for whatever reason. I didn't get this portion. All right, so what we want to do is basically get this little mixture that we just made, and we're gonna pour it into our little plastic hard tubing. And I basically made it out of this exact thing. I just went over it with the torch and I bended it to this shape. All right, so we're gonna add this in there. There you go. All right, so to help it cool down and freeze, see, it's already pretty much sticky. So that's the gelatin I added. You just buy that at the store. I'm not promoting any brand, so we just gotta cover these up real quick. All right, so we're not promoting any brand. We gotta cover those up. All right, so basically just stick this in the freezer. You're gonna see me in this video take this out twice because I spilled this up the first time and then I had to go back. All right, so that's pretty much it. And then another thing that I forgot to mention in this video is that the electrical current, everything's based off of hydrogen, and lithium and fluoride ions are the most strongest. Lithium's the strongest in the positive, and the fluorine is strongest in the negative. I believe that was right. Yeah, so just check the charges. But yeah, those are really important things. So when people talk about lithium ion, well, if they combine lithium ion with a fluoride ion, you get pretty much the strongest electrical difference that I know of. But remember, everything, the voltage everything's based off of hydrogen. That's pretty much all I could think of. So I hope you guys enjoy this video. Hopefully you guys take a little laugh. But yeah, that's pretty much it. I hope you enjoy. Thank you. Oh, also, I forgot to add, you could also make batteries off of solids. For example, like heart, your heart, what's called synthetic hearts or whatever. They're made out of physical material that they basically react with each other, and one transfers the electron, and that basically provides your electrical current. So with these solids, basically, like in 10 years, how they manufacture these in 10 years or something like that, the heart, the synthetic heart, it basically will stop working. But before that time, since we know when it's going to stop working, they basically, what a doctor does, goes back in there and puts in a new heart for you. But that's pretty much how this works. And like I said, so it doesn't drip. I'm going to put this in the freezer, as you saw, so just refill it up real quick. But that's pretty much it. That's how you make the little salt bridge. Remember, go to hcbchemistry.com and get this up. Get that salt right there. And And yeah, well, thank you, and I hope I get enough viewers and subscribers to follow this channel so I can just go live. And I got a guest list, so I'm gonna have a few select people that I admire or I think are worthy to be in this science channel. And I hope you guys enjoy and join me for future videos. But thank you. All right, my sexy people. Sorry, we had to take a little recess break. All right, so everything's just back in order. So I had to walk the dogs and then do everything. So that little, so let's recess everything we did. So I cut a little piece of this hard tubing, put a little fire, bended it. We did a little mixture of salt and then some of the gelatin, and we got a little packet that we emptied. And we basically poured it back inside the little tube. Once we heat it up, make sure you watch that part. And that's where we're left off, and everything's basically where we're at. And to cool it down, I just threw it in the freezer, and then right now it's in the fridge. So I walked the dogs and then I put it in the fridge. But anyways, that's all what happened. So let's continue what we're doing. All right, so to make a battery. All right, so basically I'm gonna grab some vinegar and some baking soda real quick, and let me show you something real quick. I almost dropped my glass because I put some hand lotion on my hands. But anyways, I'm gonna grab some little vinegar real quick, and I'm gonna show you guys something real quick. Make sure I'm just promoting my brand. I don't promote anybody else. But you see that? A little bit of vinegar. I should have just left it open, but we close that because it smells. All right, and then a little bit of baking soda. You see that? You know, a chemical reactions because you hear the bubbling. You hear that? And you can see the bubbles, but don't confuse it with the physical reaction, kind of like Mentos and soda. That's not a chemical reaction, that's a physical reaction. So just because it bubbles, it doesn't mean it's a chemical reaction. But I know it's a chemical reaction, okay? Hold on, let me, well, once I go over there, I gotta get some water. All right, so what we're gonna do is we're gonna add some baking soda on one end. So baking soda is gonna be our negative. You don't need to pour that much. And then we're gonna have some vinegar on one end. All right, and then on this one, we're gonna add some water, and I'll be right back. You know what I should do is just have a little opening right here on the other end so I can just get to the other side. Oh yeah, and a lot of chemistry is just basically a lot of dishwashing. All right, so I rinsed it off in tap water, but now I'm gonna rinse it off in filtered water. So this is a reverse osmosis deionized water. Make sure if you do use saltwater fish, make sure you get that type of water. At least reverse osmosis water I think is the best. I like distilled water, but sometimes distilled water, depending where you get like say if you get distilled water at Target, they add ozone to it and it will kill your fish. So don't get the one with ozone. Some people add ozone to the aquarium, but that's to sterilize and kill pathogens in there, and that's a whole different thing. But anyways, back to the topic. So I'm gonna add some fresh water to the baking soda. Oh, and basically, I'm pretty sure I already mentioned it, but chemistry is a lot of dishwashing. At least the lab portion of it. Bam. See that? Make the glass glow a little bit. Get that away from my light source. Got my little stirring rod. Little stirring stick right there. Alright, so I'm gonna take the other end that I didn't use for the gelatin, which apparently I grabbed, and stirred the baking soda. I'm just gonna be like a bam, you see that? That's what all the cool people do. All right, put that down. So I got 2 solutions. All right, so let's make sure I get this right. All right, guys, sorry. It's just that every 10 minutes I have to press record, and I forgot I don't even know what was the last thing you guys heard me say. But anyways, so here's a positive end. I mean the negative end and the positive end. So the carbonate is basically the one that's gonna send the electromagnetic wave to the positive end, which the vinegar is at, because there's a lot of H plus in the water. And basically, in the lab, I'm not sure if I caught it on camera, but basically let me explain it again. So let's say this is a solution of zinc. So I would add a piece of zinc, a solid piece of zinc metal in here, and basically connect the wiring to the LED light, because this LED light, because at least mine right here, they run on direct current. I'm pretty sure LEDs run on direct current, so it's converting. So there's going to be a converter from AC to DC, and we're basically making a DC battery, or a direct current battery. Sorry, alternating current to direct current. Let's not use abbreviations. And then let's say this is a piece of magnesium solution. Let's say magnesium sulfate and zinc sulfate. Okay, so I would have my piece of magnesium strip right here, which would be the positive end, and basically all the electricity will travel from the more negative to the more positive, and every solution, no matter what it is, it's either more negative than the other or more positive than the other, depending on, or however you want to look at it. Okay, so in this case, so what's happening here is I got the piece of sodium sodium carbonate in this solution, and I got acetic acid or vinegar in that solution, in this solution. All right, in the lab. So so let me explain what happening with the zinc. So in the zinc, when it's reacting, let's say there's a piece of zinc sulfate, it basically the negative end will start dissolving, and in the positive end it'll start building up more of the reactant side, whatever it is. Let's say more metal. It will form more zinc metal. I mean more magnesium metal on this side. But in the lab we use platinum, so it doesn't dissolve. So I'm gonna I'm gonna use the next best thing. So if you look at your activity series in the lab, basically what you want to do is activity series in the chemistry book. Go to it and you're gonna see platinum, gold, silver, and then copper in that somewhat in that order. Okay, and basically it depends on how much they react. That's basically all it is. So I'm gonna use copper. Okay, and I'm gonna hook everything up and just keep going. And basically in a little bit, basically what I'm gonna do is put re-record on the camera, because I can only record every 10 minutes and I don't know how long it's been right now. But let me just hook the first one up and then I'm gonna reset the camera. Okay, or at least hook up one end. All right, so which one's the correct? Is it red's negative, or black's more negative, or what is it? I forgot. And I'm gonna press pause real quick and leave these where they're at, and then I'm gonna press record again. All right, so hold up real quick. All right, another 10 minutes. All right, so let's do this real quick. Let's see what I'm actually hearing. All right. So remember, all right, let's say for instance black's more negative. I don't know. I think that's what they go, right? Black's more negative. So we're gonna hook this up. So I like this one because it had the little holes in there. So I'm just gonna like, bam, right there, right? So it's gonna be my first probe. Man, I didn't want to touch the bottom of that, but it's whatever. Science. Bam. So let's go right there. I mean, it might react with the metal in here. So I wish this was a little bit longer. Or I should just stretch it out a little bit better. But anyways, let's say the red's positive. Right? That's what they say in mechanical crap or whatever. I don't know. I wouldn't know. All right, bam. All right, so I'm running everything through copper wire, and basically I'm using copper probes. Okay, so this is my anode, and this is my cathode, or this is the negative end, and this is the positive end. Okay, so now we're gonna hook it up to the LED light. And it should start. Oh man, this is gonna be a pain in the butt to open. Oh no, it's not. So I'm getting the raw, uncut. Well, mostly uncut. Oh snap! You should never touch the light bulb with your hand. Assistance. Be right there. Honestly, it doesn't matter. I just have a lot of. I got lotion on my hand. All right, so we're gonna connect it with the negative end and the positive end. So Henry, how do you know which one's which? I don't know. We're just gonna connect it. But if it's not right, it won't turn on for sure. That's for sure. And you want to make sure it's not. They're not touching each other. All right. Bam, just like that, and then they should start. Bam. Oh snap! So what the hell is happening? It's not starting. Maybe if I switch it around, right? So I gotta switch it around, because the negative is the negative and the positive is the positive. Bam! Oh snap! Wait. Bam! Look at that! Oh yeah! Look at that sexiness right there. Look at that. Wait, but it's not starting yet. All right, so what am I missing, guys? So the way batteries work, all right, or what's happening here is that in order for a battery to work, this has to be electrically neutral, and this has to be electrically neutral. So the it's not electrons, so I'm gonna call it waves. So the electromagnetic waves going this way, and in physics, the electromagnetic wave goes one way, and the the electron wave goes this way, and the magnetic wave goes the other way. But let's say the electricity or the electromagnetic wave goes from the negative end to the positive end, which is the red, okay? And what's it called? And basically it goes over here, right? But this side is using up the electron, which it's the electromagnetic wave or the electron, and basically it's not becoming electrically neutral. And in order for the battery to work, both sides have to be electrically neutral. So what I need to add is the little salt bridge. So the positive end is gonna go one way, and the negative end is gonna go the other way. So let me go grab the what's it called, my the little salt bridge real quick. All right, guys, hold on. Let me go press pause on my camera and then redo it, and then let me reassess. But anyways, what's gonna happen is have your safety glasses on. So anyway, what's gonna happen is let me just press pause. Hold on. So basically, one salt. So the negative chlorine atom is gonna go one way, and the positive sodium atom is going to go the other way, okay? Because we use sodium chloride mostly for our salt bridge. But hold on, let me press record because I'm not sure how long it's been. Oh wait. My bad. I pressed pause on that when I was supposed to press pause on that camera. So hold up. All right, so we're gonna keep it going. So I press pause, and let me make sure which one, even though I should know, but let me just double check. Okay. All right, so I had to double check. All right, so as I said, so the negative chlorine atom is going to go into this solution, which is going to maintain everything electrically neutral, and on this solution, and then the positive sodium atom is going to go on the positive end to maintain this electrically neutral. Okay. Obviously, can't believe I forgot it. Obviously, I have to review a little bit, but I know what I'm talking about. But anyways, what's happening with the chlorine atom, when it dissolves in solution, it basically forms hydrochloric acid, and hydrochloric acid is a very strong acid. And what that means, and when you drop it in water, it's gonna disassociate, or basically it's gonna disassociate and form aqueous solution of hydrochloric acid. On both hydrogen is going to form H3, and the H3O, which basically acid, or H plus, and the chlorine atom, and it's basically going to dissolve in the water, okay, and form an aqueous solution of chlorine. And then on the sodium side, basically what's gonna happen is it's gonna dissolve in there, and like I said, sodium is going to basically form sodium hydroxide, and like I said, the sodium hydroxide fully dissociates or dissolves in water because it's a strong base, and it's going to dissolve the strong base into the weak acid of vinegar or of acetic acid. But anyways, that's what's going to happen. And like I said, sodium will, no matter how you look at it, whether it's sodium hydroxide and you know it's automatically dissolved, or if you think of sodium as a solid metal dissolved in, or we put it in water, it's going to form a violent, or it's going to do a violent reaction and dissolve the sodium metal into the liquid water. Okay, so that's basically everything that's happening in a nutshell, and hopefully that made sense. And I always got to watch out for time. But anyway, let's put it in there and hopefully it works. Oh snap. And it's not working. All right, so hopefully this is all that I need, is just move the light bulb from one end to the other end, right? Damn it, it's not even working. All right. It might take too many volts to power that up. So we're going to have to find something else to power up. So I'll press pause and then we'll be right back. Otherwise, I'm going to have to get something else to react. But I'll be right back. All right, my sexy people. So this experiment has been a major failure. I can't find anything that's battery powered. Wait, actually, I got my little microscope. It might work. But anyways, what's supposed to happen? That this was supposed to turn on, but it's not turning on. I think maybe the voltage is not big enough, or the LED light runs on alternating current and not direct current. So remember, I used black as the negative and the red as the positive. So and I switched them, but it's not working. So let me go try my microscope, and that's the last bit. Otherwise, this experiment's been a major fail, and just disregard everything I just said. All right, so let me go grab my microscope. Snap. Go talk to someone that's in the food industry. Ask them what they use to make something solid, like gelatin or agar or whatever. Ogre. I think it's called ogre. Whatever. I don't know. I forgot what it's called. But anyways, so this is my little okay, my little telescope. I can't even think anymore. So, but anyways, so here's my little microscope. I still got water on my table from the. I still got water on the table from. Let me make sure I can hear myself. All right, sorry, sound quality. So here's my little microscope, and where's my little cap? Who's that? It's too many bright lights here. Okay, here it is. So many bright lights. I can actually use my glasses to see it, and try taking them off and I can't. But anyways, so here's my little cap, and then my little light works. So I know the battery works, and I haven't messed it up yet. So I'm gonna connect the negative, or the sodium carbonate side, to the spring, if I remember correctly. And then I forgot how they make these damn batteries. Yeah, so the spring side, I'm gonna connect the black one, and on the positive, I'm gonna connect the red end. And remember, I don't want to mix them up because I don't want to mess up my little telescope. I mean, my little microscope. But yeah, so let's do that. Raw and uncut. And like I said, let me go grab my my little salt bridge, and then plug this all in, and we'll get it working. Let me not use that. Let me put this over there because I'm not messing on anything over there. But yeah, that's the best I could do. But I'm gonna let this go off a little bit, and then hopefully it circulates the electric current throughout the system. But yeah, let me go grab the salt bridge real quick. Alright, I should have maintained it nice, and like I said, I should have added more gelatin to it. So I'm trying not to touch it and try to insulate it with the towel. So like I said, we're gonna hook this up, and then we're gonna toss in the salt bridge to test my little theory that, well, I know it dissolved, so it dissolved in solution, so that's why it turned off the thing. But let me make sure it's on position. So you see that? So let me turn off all my light sources, and then most of my light sources, and then we'll I'm just gonna turn off the main ones, and then one of the main ones I can't leave. I left the other one off. Yeah. Turn off my light sources. And how long am I in there? So I'm 5 minutes in. I don't know if I should reset the camera. Yeah, let me press pause in the camera because I can see it. Now let's just keep going. So 5 minutes in. All right, so let's do this in. Well, let me just set this up, and then before I toss the salt bridge, I'll press pause on the camera. Okay. So I'm gonna put this so it's on. See that? And then I'm gonna put the negative on the spring, because that's how they make batteries. But yeah, let me press pause real quick. I mean, let me restart the camera real quick because I don't know how to do that. Alright. Alright, team. So I got this all hooked up. So now let me turn off all my light sources and point the microscope towards you guys and see if it turns on, okay? Oh wait, it's not gonna turn on because we're forgetting the salt bridge. So as soon as I place the salt bridge, I was like, why the hell is it not turning on? Alright, so as soon as I place the salt bridge, it should turn on. Hopefully. Oh snap, you saw that? It's on, you see that? It's on. Oh my god, it's freaking on. Okay, finally. We got it to work, so I'm so freaking tired. Okay, so the salt bridge is on and the light turned on. I know it's a freaking miracle. Team, everything I said is correct. And I don't want to mix it up because I don't want to mess up my microscope. But if you want to find out what happens if I mix up the current, because remember your car also works the same way. So this might even jumpstart your car. Your car might just need a little bit of juice, and this might even, like I said, we just made it right here, a little jump starter right here. It's gonna run you $100 to watch this video. Please leave the money and yeah, thank you. You know, that's all I can say. But look at that, we started the light. You see that? You see it? That's really cool. You see that? Turn it off, on, and a whole bunch of times. You see that? That's really cool. So that's how you make a battery, guys. So let me turn on all my light sources. But we got it operating. You see that? That's how cool it is. Oh my god, we got it going. Oh my god, hold on. Alright, hold up guys, I gotta do this shit real quick. Alright, so you saw that. So actually, like everything that totally works. Like I said, I'm not gonna mess it up, but you saw the light, and I can see the camera light on my main camera is working. So let me turn on my little GoPro, see if you actually see it on there. See that? It's turned on. That's really cool. But yeah, just to let you know that it works. I think it's lasting a little bit longer because the salt bridge. But do you guys know how long it would stop working? Please write it in the comments, and if you get it right, you get 1,000,000 points, and each point you could donate it to charity of your choice, and each point represents a compliment. So please write down your comments and tell me when this light's actually going to turn off, and theoretically when it's going to turn off, and then you get the 1,000,000 points and donate it to your favorite charity of choice, and they'll get 1,000,000 compliments, and I'll make sure they all get them. You just let them know. But anyways, you gotta get it right. Charity of choice gets 1,000,000 points. But we're just gonna leave it on as much as we can. See, it's going off and on because I can't hold this thing on there. But the concept's there. But right now, oh snap! We just made a portable battery. Oh yeah, so what happens? Let's say what happens if you get these thingies mixed up. What do you think is gonna happen? So we're gonna swap out the electrode, the black wire, with the other one. Oh wait, let me disconnect this also. I don't want to mess up. I don't want to mess up my thingy. So we're gonna connect the black wire with the vinegar side, as long as the salt bridge holds up. All right, so as long as the salt bridge holds up, we're gonna connect that to the vinegar side. See that? You see it? Did I do this right again? So we did the black was negative, and this is the negative solution, and this is the positive now. So okay. If you're not, just rewind the video. Hopefully it didn't mess up, because we're gonna see if it's gonna mess up my thing. But if I remember correctly, that's how we did it the first time. Otherwise, I messed up my whole thing, right? All right. So then we gotta reanalyze everything so we don't mess up my microscope. So this is the negative solution. It's gonna go to the negative end. So red is now negative. So the negative end, which is, hold on, which is the little springy again, and then Let me go check how many minutes I got on my camera real quick. Oh snap! All right, guys. Let me go reset my camera real quick. Like I said, everything's raw and uncut. All right, so my camera, I reset it up. So I got the red wire. So now the black is now gonna go onto the positive end of the microscope. Otherwise, I just messed up my microscope. Otherwise, rewind this and we're gonna find out if I messed it up. Let me put on my headgear, check the audio quality. See, now I know if I'm talking a lot better. So all right, so we're gonna put the black on with, man, this is a lot of work. So we're gonna put the black with the positive end of the microscope, and we're gonna see if it turns on. And I see that thing's good. And you see that? So the whole red and black and all that stuff, if red is black or red is negative or black's negative positive or whatever it is, I don't know what that's saying. That doesn't really matter. You know why? Put it in the comments below. Tell me why. I answered that question earlier, but if you were paying attention, you'll know. So this is gonna separate my elites from the Joes. All right. So the answer is because it's all made out of copper, and I said in the lab we use platinum probes, but I'm using copper probes. But we still use these same wires just to do basic experiments. And this wire is made out of copper because the copper is really good at conducting. And you can see it's turning on the microscope. And yeah, so we're gonna try to leave it there. So anyways, the answer earlier to the earlier question is when does battery stop working, or when does theoretically this stop working? And that's when the whole reactant side of the chemical equation produces all the product side. So basically, it's not until the whole chemical is used up, kind of like if I pour these together, that it'll stop working. So basically, this one will dissolve away and form this thing into aqueous solution, the little probe, or theoretically the probe. But over here, I think I'm getting them mixed up because I'm so tired. And then on this side, it forms a solid. Okay, so on this side it forms a solid. This side dissolves, and whichever one's the lesser of the concentration, usually that's when the thing stops working. But it's usually when it forms an equilibrium. At the equilibrium point, it will just stop working, or when the reactants or the stop. Which the limiting factor, basically, that's what they use in chemistry. But I'm trying not to say chemistry terms, but whatever is the limiting factor of the chemicals, that's when this stops working. And all right, so what I'm trying to ask now is trying to keep this on. It's whatever. All right, so I wish I don't have my little clamp, but I was just clamping on there. But so now that you guys witness what a battery, or you see me produce a working battery that actually produces a current, let me ask you this question. This is actually going to separate my true elites from the other ones. Is hold on, let me check before I ask that question. Let me go check the minutes on my camera real quick. All right, I got 5 more minutes. So I mean, on this section until I had to press it again. All right, so let me ask you guys. So what is a battery? That is a real question. What is a battery? You saw me pour vinegar and baking soda together, and you saw it react. So this is the baking soda, right, on this side. I added a little bit of water. You know, let's just do it exactly what it is. I add a little bit of water, right? Bam, right there. All right, so a little bit of water, and then a little bit of. We're not sponsoring anybody besides me. Yeah, exactly. Bam. Oh, I didn't know my GoPro was still playing. That's crazy. All right, so I'm gonna pour this right in there, and that's what happens. You see that? And that's a battery, right? So you saw that, and then you saw this. So what is a battery? And that's what's gonna separate my true elites from the rest. I'm just making sure everything's recording and my audio is good, because otherwise I don't want to do this whole experiment, because it's not gonna be authentic. It's gonna sound like fake and shit. But anyways, yeah. So what is a battery? You saw that, and you saw when this got all used up. So let's talk chemistry now. So when the chemical reaction was all used up, that's when the battery, and then when you shake the battery, let's say your car battery runs out of juice, shake your battery, because I've done this before a lot. Shake the battery, and then in your car, shake the battery in your car, and then you might be able to start it. Just give it a little bit, just keep wiggling it, and then you'll be able to spark it up if that's all you need. And your battery was good previously. If your battery was screwed up from the beginning, still shake it, and you might need to shake it a little bit extra good. You might get a little extra spark to start your car. But okay, see, this is still going. See that? That's crazy. So what's a battery? That's the question. So you saw me with a little bit of baking soda and vinegar. I'm able to start my little microscope, and that's really cool. You see that? This is $1 game. We just made a battery industry, because in HCB physics, all we do is form unlimited corporations through physics. You see that? Because we're gonna explore the cosmos by exploring. We're gonna explore the cosmos by creating unlimited corporations through physics. You see that? And right now we're making a battery corporation. You see that? You see that, kids? We're gonna get rich. We're gonna get rich. Look at that. See that, kids? Nobody's gonna give you this type of gain. Nobody but me. All right. So what is a battery? All right. So that's the final question. So yeah, that's really cool. So yeah, that pretty much wraps everything up. So please explain to me what's a battery. And remember, if you want to get the salt to make this, go to hcbchemistry.com. Make sure you go and ask me for the 1 gallon mixtures. It's gonna run you, I forgot how much is the price, but it's not that expensive. Well, actually, the 1 gallon mixture is pretty expensive compared to if you just bought a 5 gallon mixture, because they're usually harder to make. But normal price is 55 cents a gallon. I know the 1 gallon mixtures, I think it's like double that or something like that. You might want to check that. So for like about $1 or $2-3, this is it's probably like a $3 mixture or whatever right here. But this is just for your water changes for your aquarium, and like I said, this is not that expensive. I just know it's 55 cents a gallon, whatever that equals to. So 55 cents a gallon. A gallon is 3.78 liters. So do the math, okay? And like I said, this starts right there. But yeah, my website, you'll get that right there. And this is my little biological award, biosafety training. And then this is my first place in physics. And then this is my experiment, my battery. We made all the little kids rich. All the young men and women of the future. We just made them rich with a battery right there. And like I said, nobody's giving you this kind of gain in a survival situation. This right here might just even start a fire right there. But I'm not even gonna touch those together either, even though I already did earlier. Just rewind that. But what happens when you touch these? You see that it should still react a little bit, but you just can't see it. But this whole thing's still good. You see that? Bam. Let me go check the minutes on my camera. Continue my outro, because I already know what I'm gonna say. But let me just make sure I got enough time on my camera. All right, team. That was good that what's called that I want to go check because I only had 11 seconds. So now I got to now I got a good fresh. So this is gonna be the last segment of the whole experiment. So remember, this works. The light still works, and I got free light. Like I said, free energy right here. So how do I convert AC to DC? So this is direct current, and what the hell is alternating current? So imagine I had a little magnet right here, right? A positive magnet and a negative magnet, and then I would hook these up right here, right? And as soon as the magnet turns, or hold on, that's a yeah. So as soon as let's say I got a magnet right here, and then I got this connected on one end to make this positive, or make them actually let's rebuild everything. All right, let's say I got a little motor, and the little motor is spinning, and as the little magnet's going from positive to negative, it's creating alternating current. You see that from the positive end of the magnet to the negative end, or the positive end of the battery. I mean of the magnet outside, and the positive end right here that's rotating, and right here's the other end of the whatever, positive and negative, whatever. And then it's just spinning. Let's say you have a spinning magnet, and then basically it's just alternating. Okay, that's basically what alternating current is. I'll go with that later. It's easier. It's better to show you, but I just don't got the stuff to show you than explain to you. Like if I were to explain this to you, this would be even crazy to explain to you. But anyways, and like I said, I'm not gonna edit anything out. Whatever I said, it's whatever it is. And like I said, that's the battery. So anyways, what is a battery? All right, so if you haven't figured it out, what a battery is, it's basically a controlled chemical reaction. That's what a battery is. All batteries, that's all it is, a controlled chemical reaction. Doesn't matter if it's the battery on your phone, battery in your car, your batteries that you use for your solar power, or your battery, whatever it is, it doesn't matter. So what makes some batteries rechargeable and others not? It's just that this is all an equilibrium reaction. So what does that mean? Or it's a redox reaction, but it's also equilibrium reaction. So like I said, this whole thing's maintaining neutral, these two cells. So the negative end, and then this is the positive end. They're maintaining what's called neutral. They're being neutral through the salt bridge, and that's what completes the current and maintains that neutral. So the waves, the electric waves could circulate. And remember, in physics, the electricity goes one way and the magnetism goes the other way. But yeah, so yeah, I just keep thinking about that camera, how long I have to go. But yeah, so anyways, that's what a battery is basically a controlled chemical reaction. And you get the salt to do this at home at my website, and I'm pretty sure you get baking soda anywhere. Anywhere you get a cooking, you get this at the cooking hardware, so all the kids could do this. You could do this with your kids. The gelatin stuff, just go to the gelatin section. I believe I got these at the, or actually I didn't get these. I asked my bro to get them for my brother to get them for me. And he got this at the gas station, I believe. And he got me two. They were pretty cheap. I think he got them for like $1 for both of them. And I said I would add all of it to make it more to thicken the whole thing, to actually make it actual jello. Like I said, that one's actually working, so I don't know. Maybe I short-circuited it or something when I put these together earlier, or actually when I spilled the whole thing, because I still got to clean this up because I still see liquid there. But anyway, you see that it's still working. And like I said, it's not until the whole thing reacts that it's gonna stop working. And I got my little GoPro action going still right there. Still recording. And then let me just finish that. So I told you about what a battery is. I'm trying to think of anything else I need to say. But see that? I could probably light up my little fish tank with that. Nah, I'm just playing. This could probably be a good little moonlight for your fish tank. See that? So we just made a little light for our fish tank, the moonlight for our fish tank. So when I turn this one off, put my little moonlight right there. But like I said, this original light bulb, it just didn't work. Like I said, it's either I don't think it's broken because I just got it out of the thing. I just think it's either alternating current that it requires for this to turn on, or the voltage wasn't strong enough. And if it's not strong enough, what you want to do is just have more stronger chemicals to use. But we're just keeping it kid friendly and everything. Well, it's kid friendly as possible. You don't want to drink none of that. That's pretty nasty. Drink vinegar, but I'm pretty sure people do that. But anyways, so what this is basically is the neutral, the product side, and then just basically everything's all neutralized. So yeah, it's not until that basically becomes this that stops working. So let me go check the thingy on my phone real quick. All right, I got 3 minutes left, but let me restart the camera real quick. All right, guys, so everything's a success. And like I said, if you guys want to know more stories, and like I said, this is just the first episode and actually work. And there's stories for everything, like this microphone. There's a story to my cyber presence. Like in the podcast I was in, there's a story to this reward. A story with this microscope. I mean, story to everything. And like I said, and if you want to find out what happens if I mix these, like let's say if I short circuit and let's say I do it opposite, I put the black one with that's positive, so I put the black with the negative, and that's negative, so the negative with the positive. Let's see what happens. So no, I'm just playing, I'm not gonna mess up my thing. So if you want to know what happens if I do this and donate another microscope, and I'll do it, even though I already know what's gonna happen, but we're gonna leave that for your curiosity, so you could join me next time. But next time, what I'm actually gonna do is that we're gonna extract DNA next time. So yeah, so be prepared for that. So we're gonna do some DNA. There's the light again. I just love this. I'm just so happy it actually worked. So we're gonna do the DNA. We got a whole bunch of experiments that we're gonna do right here at the top secret, Matt Henry's top secret laboratory. So yeah, so Henry's top secret laboratory. I don't even know what I wrote back there, but yeah. So anyways, this is the HCB physics, and like I said, this is my laboratory portion of this channel. And like I said, go to my HCB chemistry channel and learn everything about fish tanks. If you want to see how I got this aquarium set up and looking exactly how it is, mine is right now is actually the off light cycle, but it doesn't, yeah, that makes sense still in normal terms. So the light cycle, it's either on or off, but right now it's supposed to be off, but I forced it to turn on, as you guys saw for this video. But yeah, so that still works. I just love saying that, man. I'm just so happy it worked. Like you guys could obviously tell, I'm so happy and excited to actually work, because this freaking LED didn't work. So I was like, man, disregard everything I said, but everything worked. And like I said, I didn't win first prize for that, but like I said, there's a story to everything. And like I said, I'm just trying to give you guys everything up to date. And like I said, I'm gonna be doing on my other channel, I'm gonna be doing lives and everything I can about this fish tank and show you guys what's up. All right, guys, I'm about to go off my GoPro. So I'm gonna go off the GoPro. All right, so yeah, so everything. I'm just gonna get you guys up to date. My camera it overheated, so it automatically shut off, and I hope it has still have that footage. But even if I don't, it was the last 10-minute segment. But yeah, thank you guys for joining me, and make sure you join me next time. Like I said, we're gonna extract DNA, and then I'm gonna show you guys what to do with this battery to separate the DNA and all this stuff. So like I said, just a lot of experiments that are gonna come up. And make sure you join. Like I said, make sure you join. But that's pretty much it. Let me go see if I can turn on my camera. But that's pretty much it, guys. Thank you for watching. All right, guys. So my camera turned off. So the GoPro's still going. So I'll be able to add that piece. But I'm hoping I was able to record the last segment. I totally forgot what I said. So my main camera is on. The GoPro's still going, but this still works. I'm happy everything works. Everything worked out. And like I said, I'm gonna extract DNA next time, and I'm gonna show you guys what to do with the battery to separate the DNA. Even though I might not have that portion of the experiment ready. And if you guys want to find out what happens if I mix the wiring up, what would happen like with this, I know if you mix the wiring up, if let's say if you're gonna start the car, the reason they say black is this, such as that, that's so you don't mess it up. The normal person doesn't mess it up. And as long as you keep, doesn't matter what wire you plug in, as long as you have the positive with the positive and the negative with the negative, it doesn't matter the color. Okay. But I forgot what the saying is, but whatever the saying is, make sure you man, make sure my camera's on. Make sure you make sure that's on. Make sure you get the same charges correct. Okay, that's all I'm saying. Make sure the charges are correct from one solution to the piece of machinery or electrical work that's going to provide work. In this case, it's to turn on the light. So we're going to go from chemical energy to light. So that's what all batteries are. Oh, anyways, I remember what I was going to say. So so this battery, so also the rechargeable batteries, what makes a battery rechargeable is that you're changing the standard temperature and pressure. Okay, so each chemical basically each chemical the chemical reactions that we do for batteries, they change under standard temperatures and pressure. So what that means is that depending on the standard temperature and pressure of the environment, it's going to favor either the product side or the reactant side. And if you change either the pressure, it'll favor one or the other. And if you change the temperature, it'll favor one or the other. But when we do with batteries, that another way to change it is to put energy into it, and it'll favor the reactant, the reactant side or the things before the reaction. So it'll favor these things separated, and then once you start doing work, you use it up again. And if you change the pressure or the temperature, it'll either favor this or the final product. And the temperature and the pressure, like no matter what you change, you'll favor either this or that. So that's what happens down in Earth. All right, so that's how rechargeable. I mean, the pressures and temperatures change the deeper you go to Earth, and that's why rocks and all this stuff form, like diamonds and stuff like that. It's because you're changing the standard temperature and pressure. And before I continue with standard temperature and pressure, I'm gonna go check the minutes on my camera, and let me press pause, re-record on that camera, just so I get to talk about what I want to talk about, so I don't lose the image and that camera doesn't overheat. All right, guys, I'm in my last 7 minutes. I sort of forgot everything I was gonna say again, but yeah. So that's how we recharge the batteries. Change the standard temperature and pressure. Oh, now I remember. So I'm not up to date. What's the current chemistry and all that stuff? What the terms are? But back when I was doing it, or I'm still doing it, I'm supposed to be up to date. But I use standard temperature and pressure is 1 atmosphere, which is 1 Earth's atmosphere of pressure. And then gases, we do partial atmospheres, or it just goes by 2 atmospheres or 3 point something atmospheres. And they're always talking about Earth's atmospheres, but they might have changed that. And then temperature, I forgot the temperature. What was the standard temperature? I want to say 78, but I forgot what was the standard temperature. But it's between 70 and 80 degrees Fahrenheit. To convert to Celsius, I just remember 9/5 plus 32, or 5/9 minus 32, something like that. That's all I remember. Go review. But yeah, so I got 7 minutes on that. But yeah, anyways, that's pretty much the end of everything. And like I said, this still works. Like I said, if you want to find out everything, just stay tuned. Thank you guys for watching, and I love you guys. And I want to thank all my elites for actually posting a comment, and hopefully you guys find this channel entertaining. And I want to thank everybody that made this possible, for my presence online and everything. Thank everybody. Man, thank everybody. Yeah. Think of the creators, right, and the master manipulators of the universe. But anyways, that's pretty much it. See that? Look at that. I'm so happy. But yeah, let's cut the camera. We're done. And yeah, thank you. We're just gonna do all the edits, and thank you guys for watching. Yeah, I can't think of anything. Go to hcbchemistry.com and get the salt today. And yeah, so yeah, that's pretty much it. Thank you guys for watching. And remember, join me next time as I extract DNA, and different videos, we're gonna do different stuff. But next time we're gonna extract DNA, and I'm gonna show you guys what to do with the battery, okay, that we just created, which is still working. And I'm gonna clean this mess up. And thank you guys for watching my first episode. And yeah, that's pretty much it.